Hi, we're going to do a couple of examples where we find the area between two curves. In this particular example I'm doing is from Chapter 7, Section 1, number 25. Now it's going to make your life a lot easier if you can figure out a way to graph these. I'm using GeoGebra myself, so if anyone's interested in figuring out how to use this software, please just let me know. So on 25 I've graphed our quadratic, which is x squared plus 2x. And that's the parabola shown here. And then I've also graphed our linear function, which is x plus 2, and that's the line going here. And what we're doing on these problems is finding the area between the two curves. I see they intersect here at -2, 0, and here at 1, 3. And now I'm just trying to figure out what is the area in here, okay, between the two. Right? And now the way that I'm going to do that is to take the integral of the curve on top, which I know that sounds simplified, but if we look here, the linear curve is on top of the quadratic, so we're going to list it first, subtract the one on bottom. Okay, so I've got the x plus 2 that was on top, subtract the x squared plus 2x, and now I'm integrating from -2 to 1. And that simply comes from where they intersect. Notice they intersect here at x equals -2 up to 1, and they intersect again here at 1, so that's where my integral is coming from. So from here we just simply need to do the integral. All right, the first thing I'm going to do is actually simplify my algebra within here. I get x plus 2, subtract x squared, subtract 2x. Okay, combining my terms in there, I can rewrite this as -x squared, positive x and a -2x combined to give me a -x, and then plus the 2. And now I'm ready to integrate. -x squared becomes -x cubed over 3. -x becomes -x squared over 2, and the 2 just becomes a 2x. And now I'm going to evaluate that function from -2 to 1. So the first time through, I'm going to plug in the 1. I get -1/3 minus 1/2 plus 2. And now I'm going to subtract off the second time through. I'm going to evaluate it at -2. So I get -2 cubed is a positive 8, but then times the -1, this becomes -8 over 3. Subtract -2 squared is a positive 4 over 2. Got the negative out front, so this is -2. And then 2 times -2 is -4. Now a little fraction work. This is going to be -2 over 6 minus 3 over 6 plus 12 over 6. So my first term just becomes 7 positive over 6, still subtracting. My next term here, I get -8 over 3. I actually messed that part up. This should be positive. I said it wrong. -2 plugged into cubed makes a -8 times the negative gives me a positive 8 cubed. I mean 8 over 3. All right, and now over here I've got a -2, -4 go together to give me -6. If I want to get that as a fraction, -18 over 3 subtracted in here. So this second term becomes 8 over 3 minus 18 over 3, which is a -10 over 3. So now I have 7 over 6, the negatives become positive, and this is going to be 20 over 6 if I convert this to common denominator. So my answer is 27 over 6. Reducing that to simplest terms, I can pull a 3 out of the numerator and the denominator. So my answer is 9 over 2. Let's do one more example. Okay. Again, I'm going to start with the graph function here. I'm doing number 29. I have the square root of x plus 3 graphed here, and down here I have the linear function 1/2 x plus 3 graphed. Okay, you can see they intersect here at 0, 3 and here at 4, 5. Okay, so if I set up that integral, notice the square root function's on top, and we're going from 0 to 4. So I get 0 to 4, my square root of x plus 3, subtract off my linear function, which is 1/2 x plus 3. Again, for my first step here, I'm going to just simplify my algebra square root of x plus 3 minus a half x, and then subtract 3. So that helps some. My 3's are going to go cancel each other out. And so I'm actually integrating from 0 to 4, square root of x minus a half x dx. Okay, recall that the square root of x is the same thing as x to the 1/2. When I get ready to integrate that, it becomes 2/3 x to the 3/2. Okay, and if we integrate this, the negative 1/2 can go out front. Right, and I get x squared over 2, so this becomes negative 1/4 x squared. Okay, and now I want to evaluate that at 4 and 0. Okay. All right, plugging in my 4, the square root of 4 is 2, cube that is 8, times 2/3 gives me 16/3. Plugging in 4 here, 4 squared is 16, divided by 4 is just 4. 16 divided by 4 is 4. And now if I plug in my zeros, this is just going to be 0 and 0, so I don't have to worry about that. Okay. So I end up with 16/3, subtract 12/3, so the area is 4/3. I hope these examples help. If you need more, please just let me know.